This is some problems off the practice test for the Chapter 11 test. We're beginning here with problem 4B, and what we're asked to do in problem 4B is we are asked to find the derivative and interpret that derivative in the year 2020. And the derivative is the slope of the tangent line. So what we need is, first of all, we need to figure out the point of tangency, which would be that little blue point right there. And that little blue point appears to be, for the year 2020, the y value appears to be just less than 6, so we'll call that maybe 5.8. Now, if you decided it was a different value, you could use a different value, but I'm trying to give as close an estimate as I can. And then in order to complete what we're asked to complete, we also need a point on the red tangent line to calculate the slope. And the easiest points to pick would be either here at 2010, because we have a grid line, or here at 2030, because again we have a grid line. Now at 2010, it would appear that the y value on the red tangent line is probably about maybe 4.4, 4.5. And if we're talking about 2030, then the y value on the tangent line appears to be probably about 7. And remember, when we're looking at this, we're looking for the point on the tangent line, not on the curve. So at this point, what we want to do is we want to actually calculate the slope. And we know that the slope, which is m, is the difference in the y values divided by the difference in the x values. And so using the point of tangency as one of those two, the y value there is 5.8. And the year, of course, was 2020. And then I'm going to choose to use this point. May get a slightly different answer from what was on the key because I'm basing this on my best guess. So in 2030, the y value was about 7. And 7 minus 5.8 is about 1.2. And of course, 2030 minus 2020 is a 10-year period. So if we divide that by 10, that means that our derivative is approximately 0.12. Now, alternatively, if we had used 4.4 and 5.8, then the difference between those two would have been 1.4 divided by 10. And we would have gotten 0.7. So there's, there's some variation in the answers that you can get. But you pick either of the 2 points. So based upon the slope of the tangent line, this is the derivative, being 0.12, then the interpretation is that in 2020, the number of patients And normally I would have you write out all the details, but I'm going to skip on to the actual interpretation of the derivative. Is increasing or will be increasing by 0.12 million people per year. And the most important part to remember when we do this is that it will be increasing, not was increasing or increased, but it will be increasing, because this is in the future, by 0.12 million people per year. That word per is very important. And again, this answer is going to vary according to what you decide that the values of those points are. So in number 9, we're supposed to use the graph at the right to answer the questions. And I'm going to go ahead and answer both of them because I think it's important that we do both 9A and 9B. So we're to complete these statements about whether or not the function is continuous. So the function, is it continuous at -3? And what we see is that the function limit from the left at -3 appears to be approximately -1. But from the right, the limit appears to be closer to +1. And since those two limits do not match, then the function is discontinuous, because even though it was defined at -3, the left-hand limit did not equal the right-hand limit, so the limit as x approached -3 did not exist. And that is the language you use. Don't tell me there's a gap or there's a jump. It's because the limit did not exist. That's your 3-step process. Now, the function is continuous or discontinuous at -1. So we look here at -1. And at -1, we see that there is an asymptote, which means the function, if you approach from the left, is going to positive infinity, and as you approach from the right is going to positive infinity. But because limits at infinity are not possible to quantify, then it is discontinuous, because the function itself, f of -1, is undefined. So it's not really the limits that are the issue, it is the fact that f of -1 is undefined. And it's also perfectly okay to say that f of -1 does not exist, because if it isn't defined, it doesn't exist. So then the third place that we'll look for the limit is when x is actually 1, and that would be here. And so if we look at what's happening with the function at 1, we see that f of 1 is defined. It appears to be 1. No, I'm sorry, it appears to be negative 1. And so that's true. So then we look and say, okay, does the limit exist? And the limit from the left appears to be negative 1, and the limit from the right appears to be negative 1. Therefore, the limit exists. And then the third step is, does the limit equal the value of the function? And the answer is yes, it does. Therefore, the function is continuous at x equals 1 because f of 1 is equal to the limit as x approaches 1. And both of those are equal to negative 1. And then the last place that we look is going to be at 2. And notice that at 2, f of 2 is defined. F of 2 is defined to be negative 3. But the limit, while it does exist from both the left and the right and matches at 0.5, the limit exists, the function exists, but the limit value does not equal the function value. So that makes it discontinuous. So the reason that that one is discontinuous is because negative 1 does not equal 0.5, negative 0.5. So then we move on to part B. And part B, you need to remember where the function was and wasn't continuous, but you also need to remember some other things. So for the value at negative 3, can we take the derivative at negative 3? And the answer is no. And the reason we can't take it at negative 3 is because the limit as x approaches negative 3 does not exist. At negative 1, we have a somewhat different situation. Number 1, the function is discontinuous there. So again, because the function is discontinuous there, and the reason the function was discontinuous, if you remember, is because it was undefined. The function is undefined at x equals negative 1. You can also say f is not continuous. At negative 1. Either one works, because either one makes the function not differentiable. It was not differentiable at negative 3 because the limit didn't exist at negative 3. It's not differentiable at negative 1 because the function is not continuous at -1, or we can say that it's undefined at -1. So then we consider 1. And looking at 1 on the function, we see that the limit exists, the value of the function exists, they are equal, it's a smooth curve at that point, so the function is differentiable. It is continuous. And it's a smooth curve. No sharp points. The function is not differentiable at 2, however, because the function is not continuous at 2. So a function is never differentiable if it's not continuous. Or if it's not smooth, and in other words, the word for it being not smooth is sharp corners or cusps. And it is also not differentiable at endpoints. Now in this case we don't know for sure if the function has an endpoint, but if we had had a closed circle at the end of this piece or at the end of this piece, whatever the values are at the end of its domain, you can't draw a unique tangent line at that point, therefore it is also not continuous at endpoints. Now problem number 10, I think what's tripping everybody up at problem number 10, especially on part B, if you get the right answer for part A, and you should because it's a relatively simple function, the derivative in part A is r prime of x, and it turns out that it's equal to 16 minus 6x, and then your units are dollars revenue per $100. This is where you're getting tripped up. Spent on advertising. And the key here, once again, is the fact that it is $1,000, but X is measured in $100 spent on advertising. So $1,000 is not what you plug into this function. X is equal to 10. $1,000 is equal to 1,000. And then R of 10 is 16 minus 6 times 10, which is 16 minus 60, which is $44, because revenue is in dollars. X is in $100. So when 1,000 is spent on advertising, the revenue is increasing by $44 per additional $100 spent on advertising. And hopefully that will clear that issue up for you. So if you have other questions, I will do my best to answer them before the test. I have a couple of other short recordings I'm going to do for a couple of problems that didn't fit on this one, and I'm going to post these in Shobi.